Okay, so this is a little demonstration of reading the solar panel voltages from the FunSim while it's rotating. If you can hear a whirring noise in the background, that's a rather Heath Robinson turntable device running on a little 1.5 volt motor with a bit of a gear train, so I hope it's not too distracting. But I'll leave this little picture up in the top left of the screen, so where you can see the simulator going around. Here's one of the solar panels, and you'll see another one come around on another side. The reflections you can see in the perspex are of the angle poised lamp that I've got, which is simulating the sun. It's just coming into view now, and if you look carefully, you'll see that later on you'll see that the camera angle is different to the angle that the light's coming from. So here's the main menu of the what I'm calling the ground station, or the simulated ground station, and as you might have seen before, this little window gives the solar panel voltages, and ignore the bottom two because the plus or minus Z solar cells aren't fitted. These are just random voltages, but you can see as it's turning the voltages are varying, and at any one time one of them is quite high and the other three are fairly sort of low, and I can record those by pressing that button onto a file on the host PC, and it goes into a file in here called solar.txt, which is a text file. I've actually got a demo one which I recorded. It takes quite a long time to record a whole rotation's worth, so if I now open that file with a text editor, I use a little thing called TextPad, you can see what's been recorded. We have the frame number as a first field, and then the 6 voltages from each cell, so again ignoring the last two. So that's x and minus x, y and minus y, and plus and minus z, which we ignore. One of the things I can, well, by inspection I can sort of look down the columns and see, if we take this column here, which I think is the plus x-axis, you'll see as I scroll down it hits a peak level of about 75, round about here. What I can do, of course, is import this into a spreadsheet. If I get up a copy of Excel and open up a new spreadsheet, and then I can import this data into the spreadsheet. Like this. I have to have delimited with a comma and with no qualifier. So here's the data imported into a spreadsheet. It's then very easy, of course, to just plot a graph, and just a simple line graph will do that. And you can see here it's a little bit peaky at the top. I suspect that's a function of the A to D converter, but you can see there quite convincingly a bit of a sine curve. This is being done in daylight, and so there is a bit of sort of backscatter here, if you see what I mean. I can actually do, by means of comparison, the next column. And if I move this one below the previous one, you can see this is out of phase because plus x and minus y, but of a very similar shape. So that's the spreadsheet, which I just closed down for a minute, because the other thing that's I've done is you can actually plot in real time as part of the ground station, and I haven't labelled the axes, I haven't got around to it, I'm afraid. It's part of the development process, but obviously this is time going along this axis and this is voltage going up here, and you can quite clearly see the relationship between the panels. Again, it takes a little time to plot, and so I've got one that I've done previously which I can just slide into view now, and that's a complete the 4 panels, 1, 2, 3, 4. Interesting, they're at different heights because the panels actually vary. They're rather cheap ones, and I haven't calibrated the equations in the software, but that would be possible, I guess. And one of the ideas behind this is just to demonstrate how maybe one of the things that is part of the curriculum, as I understand it, is that students are required to demonstrate, or not to demonstrate, but to plot data in different formats. So they could actually take this and by plotting the frame number against the voltage on a bit of graph paper, either for one or all the other solar cells, they can actually produce a graph for themselves, and that, as I say, is part, as I understand it, of some of the curriculum for, I don't know what year it is, but at the schools, is manipulation of data and drawing conclusions, because you needn't tell them that the thing's rotating, I suppose, but they could perhaps work it out for themselves. And certainly it might be a good introduction to getting the live data from after the satellite's launched. So that completes that little bit. Thank you for watching.